Okay, let's give you guys some practice on using the squeeze theorem. But before we do, let me just recap the previous video. So we were trying to work out the limit of this. And the way we do that is to visualize it as one block multiplying another block. And this block here, we know it oscillates between 1, negative 1, 1, negative 1. So the highest value that this could be is 1, and the lowest is negative 1. So this block here, the highest value is 1, the lowest is negative 1. And then we try to write this as an inequality. So it's like this. We are trying to find out the limit of this here. Okay, but we note that this here is between the highest value that this could be is 1. So if the highest value is 1, then the whole thing here has got to be lower or equal to x squared, because if this is 1 here, then 1 times x squared will give you x squared. And the lowest value that this could be is when this block here is negative 1. And when it's negative 1, then it's got to be bigger or equal to negative x squared. Now, if you don't understand this, then watch the previous two videos. But we start out with this here, trying to solve this. But then we rewrite it in this form here. Okay, so this is our function. Yeah, this is our function here, and we know it's between here and here. And what we do is we take the limit of this and this here. So the limit of this and the limit of this here. Well, the limit of x squared as x approaches 0 would be 0. Would be 0 here, and this here is also 0, and our limit is somewhere in between 0 and 0, so it must be 0. Okay, so the trick is to write our function being trapped in between two things, and the way we know that is because this thing here is trapped in between positive 1 and negative 1. That's the only thing we use in order to write this thing here. Okay, so once it's in this form here, find the limits of this and find the limit of this, and our limit is trapped in between the two. Okay, so as it turns out, the limit of this is 0. Okay, now use the same technique on this problem here. So So the question is, find the limit of x cosine x, okay, as x approaches 0. So start out by knowing that cosine of x is being trapped in between 1 and negative 1, okay, and your y equals x, well, it's being trapped in here. Well anyway, yeah, so realize that this here is the highest value that this could be is 1, the lowest is negative 1. So fill in what goes into this bubble, what goes into this bubble, and then take the limit of this thing and this thing here, and then find out what the limit of this and the limit of this, and our limit is trapped in between this and this. Okay, well anyway, so work out the limit of this here. Okay, now so once you've got your solution here, let's say it's 7 and 7 here. The limit of this thing here is 7. The limit of this thing here is 7. Then you know that this thing here is, suppose it's 7. Then this thing here is 7. Okay, so that's the template for it. Well, anyway, so press pause and have a go. Work out the limit of this as x tends towards 0, and try and encapsulate this thing here between two things here. Well, anyway, press pause and have a go. Find the limit of this. So press pause and have a go. Okay, so we know that, well, visualize this as being one block times another block. The highest value that this whole thing could be is x. Okay, so the highest value this thing could be is x. Now, if this block here is negative 1, then the lowest value that this could be is negative x. Okay, so now take the limit of negative x. Take the limit of x here as x tends towards. So here as x tends towards 0 of this will be 0. And then if you look at this graph here, y equals negative x here. Y equals negative x here. You see, as x tends towards 0, then you can see it's heading towards 0. So the limit of negative x is actually 0. Okay, so what we want to find out is here. What we want to find out is trapped in between 0 and 0. So therefore, we can say the limit of this here is actually 0. Okay, so yeah, so hang on, let me just recap here. So this here is x, this here is minus x, and then take the limit of this. Take the limit of this. This equals 0. This equals 0. And then you can say therefore. This is a symbol for therefore. Therefore, the limit of what we want to find out is 0. Okay. Just to point out something. We were trying to find out the limit of this. Okay. You could use one of the theorems where you can break into this thing here. So you can just break into this thing here. So take the limit of this and take the limit of this, and this thing here is 0. Well, I'm just showing you that there's an easier way of doing it. Okay. Well, if I gave you this problem so that you can practice using the squeeze theorem. I gave you this here just so that you can practice using the squeeze theorem. But you could, an easier way is just to break into this thing here. So take the limit of this, take the limit of this here, and then this thing here is 0. This thing here is 0. So 0 times 0, and then it equals 0. But the thing is, you can't do that when it comes to this. You see, in one of the earlier videos, I gave you find the limit of this. Now you can't simply break into this by saying, oh, the limit of this whole thing here is, or just break into it, the limit of x squared times the limit of sine 1 over x. You can't do this because the limit of this here does not exist. So the theorem that allows you to break into this and this here says that the limit of this here has to exist, the limit of this here has to exist. You see, sine of 1 over x does not exist. This has to be ingrained inside your mind. You see, sine of x here exists. Okay, the limit of this as x approaches 0 exists. But this here does not exist, and this has to be ingrained inside your mind. The limit of this here does not exist. So you can't simply, when given this here, you can't just simply break into this because the limit of this does not exist. Whereas this one here, the one that I gave you, you can actually break into it by because the limit of this exists, the limit of this exists. So you can just break into it and say the limit of x, find the limit of x, and then find the limit of cosine of x. This here is okay because the limit of this exists and the limit of this here exists. So you can do that. But in this case here, you can't. Okay. But the reason why the reason I asked you to use the squeeze theorem is because I just want to give you some practice on trapping this whole thing by using this to trap it, trap the whole thing in this. The reason why I gave you this is because I want you to be able to do this, trap it in between x and minus x. Okay. Later on, I will give you something like this. Okay, this one here. Suppose I were to give you this here, 1 over x here. You see, you can't simply break into this now because the limit of this does not exist. So you have to use the squeeze theorem then. If I were to give you this here, 1 over x here you have to use the squeeze theorem. Okay, you have to use the squeeze theorem. If I were to give you this here, then here you don't have to use the squeeze theorem. You can use the squeeze theorem if you want to, but you don't have to. But this one here, you do have to because the limit of this does not exist. Okay?